Hello Polkadot, my name's Chris Wilson, and in this tutorial we will learn how to construct different queries that can be run against our DataHub Polkadot node to supply us with more information. Let's go ahead and navigate over to datahub.figment.io, log into our Polkadot account, scroll down, and click on Tutorial 3, Query the Polkadot Blockchain. We will be building on top of the Node.js application created in the previous tutorials, so make sure you've completed Connect to Polkadot using a DataHub node and create a Polkadot account. After what we have learned in these previous tutorials, we are now empowered with simple access to the functionality we require. We will implement our RPC provider connection to the Polkadot API using promises via the API constants as before. Let us begin by creating a new file, Query.js, and then we're going to include this code. So, just like we've done before, create the file, grab the code, and plop that in there and save. And now what we're going to be doing is populating these comments with some additional code. All right, let's get into it. Because we'll be adding in the code to make this program functional as we go, it would be a good plan to follow through each step carefully. Let's explore what this code is doing as we move forward. Query blockchain details. Add this snippet inside of our main function below line number 1. And drop that in there. Hit it with a save. The first 3 lines are going to fetch information from the API. That's these 3 lines right here, such as the runtime version, which lists the name, version numbers, and information about which APIs are supported. The Genesis hash and library info can be useful. Defining constants in this manner using the await keyword to get the data asynchronously gives us the ability to then refer to the returned information in simple terms. In other function bodies, or as template literals, it is much simpler to refer to the results of an RPC query in plain language. There's no strict requirement for constant or variable names. Developers are free to express these concepts using whichever words make the most sense to them. And the choices we have made here in the example code are by no means definitive. To wit, const chain could just as easily be const Figment, and nothing in the code would change except that $chain would no longer be a valid reference within the template literal. Instead, we would refer to that data with $Figment. Querying account details. We can add the following snippet to query account details inside of our main function. Let's go ahead and do that now. Plop it in there, hit it with a save. And now we can see here that a nonce is a number used once. In the context of blockchains, it is used to indicate how many transactions an account has performed, the nonce being incremented by 1 for each transaction. Referring to data:balance, here we are destructing the property and applying the name balance to it, so that later in our code we have a more semantically pleasing way of referencing that information. Saying that a balance is some data.free makes less sense than saying the balance has some balance.free. The referendum count is related to the governance aspect of Polkadot, where in order to make any changes to the network, the idea is to compose active token holders and the council together to administrate a network upgrade decision. No matter whether the proposal is put forth by the public dot holders or the council, it will have to go through a referendum to let all dot holders weighted by stake to enact the decision. In many cases for new accounts, this will be firmly at 0. Query validators. We can add the following snippet to line 3, or comment 3, query validator set. Come in here under 3, hit it with a save. Here we observe the stakers of the current error using map with an asynchronous callback function, async key data, to iterate over each one of the stakers and display the address, total, and own properties from the API query, errors, stakers, entries. Now, because we do not know beforehand the number of validators to display, the above snippet can possibly flood the terminal to the point that default scrollback settings will leave you unable to see the top of the output. This is a common problem when logging information that you do not know the length of beforehand. One method to easily overcome the excessive output is to determine which console.log is responsible, then comment it out. However, this is a temporary solution. As a bonus activity, capture all of the console.log output. Consider logging it to a file. We learned about this in the previous tutorial. Or the code snippet above could be modified so that it doesn't scroll the terminal excessively. Take the opportunity to try different things with the code. Read more documentation, experiment, test assumptions using what we have learned. And that's kind of the whole point of DataHub, is to give you access to the nodes so that you can experiment in a safe way. Now we can move to query list of transactions. Let's do that by adding the following snippet to comment 4, query list of transactions. Go ahead and paste that in there, hit it with a save. So we look here, we can see api.rpc.chain.getBlock will query the block hash at a specified block height. We can then format the resulting block hash data for readability using .toHuman. Additionally, isSigned returns a Boolean true or false after checking to see if the underlying API command, often referred to as an extrinsic, has an associated signature from a valid key pair. In this way, it is possible to view the encoded data from the blockchain in a human-readable format. Now we can move on to querying the blockchain metadata by adding this code snippet to comment 5, query blockchain information at a given height. We can pop that in there and save. So now we can see that using promise.all in this manner allows us to asynchronously execute several API queries. The names of the constants should be relevant to the information being requested, but there is no specific requirement for name or naming convention. It is up to developers to determine what to call their constants or variables. There are only suggestions. Forming the API query extrinsics is largely a matter of understanding the API calls necessary and placing them into our code where it makes the most sense. The first query, api.query.timestamp.now.@blockhash, is not much different from api.query.timestamp.now. It just refines our requests for the timestamp of the specific block hash by including .at. Let's query events. Add the following snippet below line 6, query events. This should all be pretty familiar with you guys by now. All right, hit it with a save. Here we need to iterate over the events being returned from the .system.events.@blockhash. Query using .for each with a callback to log each one. When using .toHuman to format the data for readability, an observant reader may notice that event.event is a little bit unusual, which is due to the fact that we are targeting the event property. Effectively, the first event is the parameter, the second event is the property. Consider the difference in the output here. All right, now we can run the code. Node Query.js. Oh, awesome. Beautiful. And that is what it looks like. Look at that. All right. Whoop, whoop. So now we can go back to DataHub and we can click Verify. Congratulations! In this tutorial, we have used the API we created to query different types of information on the Polkadot blockchain. In the next tutorial, we will be looking at different queries we can run against a Polkadot node to gather useful information. As always, if you had any difficulties following this tutorial or simply want to discuss Polkadot or DataHub tech, you can join our community forums or our Discord with the link down below. I look forward to seeing you there, and until next time, happy coding!